Now let's see what are the various algorithms that are used on the linked list that I have shown you just now, that linked list, in order to find out a hole and allocate it to the process. And these methods can be applied even for the fixed partitioning or static partitioning. Let's talk about variable partitioning. Okay. So first one is first fit. First fit means whenever you require you are required to add any. Okay, let's take this example and I'll show you. I'll better use an example here. Let us say I have a memory like this, operating system, and then there are four blocks, and one block is a hole and its address is 0 to 100, and other block is a process, its address is 100 to 199, let us say it is 0 to 99, and other block is a hole, address is 200 to 299, and other is a process, address is 300 to 399, right? And this is the organization I had. So there are two holes and there are two processes, and if you look at the linked list for this representation, it will have like this, right? Hole and starting address is 0, ending address is 99, right? And then a process, starting address is 100 and then 199, right? And then a hole, starting address is 200 and ending address is 299, and then a process, starting address is 300 and ending address is 399, right? And it is a linked list. As I told you, it is a double linked list, right? And it is the head. Fine. And now what does this first fit say is scan the entire list, right? Whenever you want to allocate any memory to a process, scan the entire list and then see whenever you find a process, the first process which is big enough to hold the first hole which is big enough to hold a process. Let us say I got a request from a process and it needs 50 bytes. This is the request I got. Then how does this first fit algorithm work is, it starts from the beginning and it scans the list and it will find out what are all the holes, and it will find out and it will stop whenever it comes across the first hole which is big enough to hold this 50 bytes, right? Let's see this. Now when it is scanning the entire list, first thing is it comes across this hole, right? And the size of this hole is 100 bytes, isn't it? So 100 is less than 50, 100 is greater than 50, and it is the first hole which is big enough to hold this 50 bytes, then it will allocate it. That is first fit. So what is first fit is, scan the entire list from the beginning, and whenever you come across any hole, what can I say, a hole which is big enough to hold the process, you give it away. Then what are the implications here? Whenever you give a hole to a process, then you have to break the hole into two parts, how much it is occupied and how much it is free. That is the beauty of this dynamic allocation, remember. So in fixed allocation, whenever you allocate a process to a block, you cannot allocate the remaining space to other one, right? But here whatever is remaining, that will form a new hole, right? So which means now if you allocate this 50 bytes here, which means if you allocate a new process here in this place, right, then what happens here is this hole will get broken into two parts. One part will say now a process is present from 0 to 49, and then the hole is from 50 to 99, right? So because of now you understood. So whenever you create any process, then the number of elements in the list are going to increase because they are going to split up, right? A process and hole, like that, right? And whenever you take a hole and allocate it to a process, it is going to split up, and it is always going to happen. And whenever you delete a process, it might merge with the other process, or it might merge with the other holes, or it might merge with or it might create a hole there. I'll just tell you what happens, right? So this is how it is happening. And then in order to implement this, we are going to maintain the list in the increasing order of the starting addresses. Now let us say after some time this process, this one got freed up, which means 100 to 199 got freed up. Then how is this algorithm going to work? See, in the PCB, if you look at, if you know that, remember that PCB, process control block, from that PCB, whenever you free up a process, whenever a process is over, there will be entry from the PCB to the node which contains the entry in this list, right? So somehow you could directly come to the node in the list for which you have to free up the memory. How is that possible? In that PCB, we can even maintain a pointer saying that see, this process was holding this memory. So whenever you try to release that process from the PCB, or whenever you are trying to stop a process and kill a process, then you can even go to this list, directly come to that point where it was allocated, it was holding some memory, and you can free up there, which means, see, you can directly come here, right? And you can now see what is adjacent. So adjacent, there are two holes, right? So whenever you try to free it up, you can create a new hole, new bigger hole, because two sides it is hole, right? So now it is a new bigger hole. It is starting from 50 and ending with 299, right? So, and now you can have the adjustments like this, right? And you can delete all this, right? Therefore, first fit is really very efficient. In the sense, it is faster to find out a node which is free to a hole which is free to hold the process. That is first thing. And second advantage is maintaining it is easy, in the sense whenever we free up any process, it is very easy to merge the holes together, right? And first fit is the most widely used algorithm among all this. And then even in malloc, so if you remember that in C there is a memory allocation function, right? Malloc, that is used to allocate the free space from the heap. And even heap is a kind of dynamic allocation, right? Dynamic partitioning. Whenever you ask for a memory element, it is going to be dynamically created in the heap, right? So even in that dynamic allocation part inside the heap, the first fit algorithm is going to be used. Now next one is next fit. Next fit says that earlier, let us say you have allocated a process here, right? So wherever you have scanned, whatever part you have scanned earlier, you start scanning from there. So what is the difference between first fit and next fit is, next fit is exactly first fit, but then we'll start scanning the list exactly at the point where we left it earlier. Let us say we have a very big list like this, and last time we allocated a hole here. Then next fit says that don't scan from the beginning, scan from this part. So next fit, the idea behind next fit is, since we have already scanned the list once, the probability of finding a hole will be better if you start from that point. But then simulations have shown that next fit is not better than first fit. So after doing this, after proposing this next fit and implementing it in some of the systems, later when they found out using simulations means we tried some experimentations and we shall see which one is better. So simulations have shown us that next fit is not really better than first fit. So first fit is better. So next fit is not really used these days. And next one is best fit. Best fit is among all the holes which are possible present, you find the smallest hole which can accommodate the process. Which means, assume, let's say I have many holes in my list like this. Let us say there are many holes in the list, and each hole is, let's say this is a process and this is a hole whose size is 20, maybe 20 MB, right? And again there is a process and there is a hole whose size is 10 MB. There is a process, there is a hole whose size is 5 MB, and there is a process like this. If you have this process, then what happens is this best fit will try to search for all the holes. Among all the holes, it will choose the smallest hole possible and will allocate it to the process. Let us say I got a process request of 4 MB, which means now a process wants 4 MB space. Then what will best fit do is, it will search all the holes. One hole is 20 MB, 10 MB and 50 MB, right? Then it will allocate the process with the smallest hole possible, which means it will allocate the process with 5 MB, right? So what will first fit do? First fit would have allocated 20 MB, but best fit would allocate 5 MB. The idea behind it is, if you allocate the smallest hole possible, then it will not waste a lot of space. That is what the idea behind it. But the problem with this best fit is, even though we could find a hole early, we are supposed to search the entire list. Therefore, it is going to take order of n time, right? So we have to search and scan the entire list and then decide which one is smaller. So one thing is it is slower because of this searching, and second thing is when we try to allocate a smallest hole to a process, the remaining space, the remaining hole is going to be very small, that it will become really useless next. The reason is it will create very small holes, and this small hole cannot be allocated to any big process or any process on average, right? So two disadvantages of this best fit is it is slower compared to first fit, and second thing is it will create very small holes, and so best fit is not actually best fit is not a practical one. So the better one is first fit. So the first fit is faster, and second thing is whenever we allocate by simulations we found out that whenever we allocate any hole using first fit, on average the hole created next because of this allocation will be larger than the hole created by the best fit, and therefore that larger hole can be used for some other process. Getting this? See, in this case first fit would have created a hole of 15 MB, I think 16 MB. If I allocate 4 MB here the whole remaining new hole created will be 16 MB, and here the new hole created will be 1 MB, and 1 MB is a smaller hole, and therefore it might not be taken up by any process. But if you create a bigger hole, larger hole, then it will be having a good impact later, right? Later a process can take it. So again, even compared with the best fit, again first fit is better. Even though name says it is best, it is not actually best. Using simulations we found out that it is not really best, it is worst. The reason is it is taking up a lot of time to search for the best one, and second thing, it is creating very small hole. And next one is worst fit. Worst fit says the same thing. You scan the entire list, and then you find that is scanning is same, but then you find the biggest biggest hole possible, and then you assign the process, right? So in worst fit, let us say this is 100 MB, not 10 MB, it is 100 MB. Then what will worst fit do is, if you have to allocate 4 MB, it will scan the entire list. See, according to first fit this is allocated, right? And according to best fit it is allocated. Now according to worst fit, it will take the largest hole, which is 100 MB, and it will try to allocate it. So when you try to allocate this 100 MB hole, what is the problem there? We get the largest hole possible, but the problem is searching for the worst case or the largest hole is again going to be a problem, isn't it? So even this worst fit is also not better than first fit, because search time is going to be very high. See, yes, the hole produced will be larger, but then the search time itself is going to be very high, right? So again, compared to worst fit, first fit turned out to be better. So next fit or best fit or worst fit, first fit turned out to be the better one, right? And then there is one more modification which is called as quick fit. Quick fit says that there are normally some process sizes which are most frequently used. Therefore it says that for all the most frequently used sizes you maintain a linked list, which means it says that maintain a linked list which will contain most frequently used sizes. Let us say most frequently used size is 2 MB, then this list will contain all the holes which are having size 2 MB, or all the holes which are having size 4 MB, all these holes which are having 8 MB. Like this, if you maintain individual lists of holes which have this capacity, then allocating them will be easy. That is what this quick fit says. Quick fit says that maintain different lists for frequently used sizes, but it is not really practical. Yes, it can be practical, but it is a waste in the sense we might have to maintain different lists, and then whenever you try to free up a process, then that is going to take a lot of time, because you have to go to the process and then find out what are the adjacent lists, and you might have to expand the whole, and it is going to be a very hectic thing. Yeah, it is quick, but then it is not very fast. In the sense, allocation is quick, but deallocation is going to take up a lot of time. And see, all these assumptions, whatever analysis I did till now, it is all based on the assumption that the list is maintained in the increasing order of the start addresses, and then it is a double linked list. But then you could do, if you are very much inclined towards implementing one particular kind of algorithm, then you might have to modify the list in such a way that this data structure will help you in implementing that algorithm fast. See this, many times the running time of algorithms depend on the data structures you are using, isn't it? So maybe you could modify the list in such a way that it will support some of the some of the algorithms. For example, for first fit you need not do anything, the increasing order of this one is going to be enough. For next fit also nothing is required, but for the best fit it will be better if you sort out the if you sort out the list in the increasing order of the sizes of the holes, which means if you sort it out in such a way that the smallest hole comes earlier and the largest hole comes at the last, if you sort it out like that, then best fit will have the same performance as the first fit, because the first one, which is a fit, is nothing but the best fit, isn't it? But it is going to have some, see what I'm trying to say is, see, let us say I have a process, a hole of size 50, and a process, a hole of size let's say 100, and a process and a hole of size 10, right? Now what is that we could do is, we could separate out the holes from the processes, and these holes could be sorted out on the increasing order of their sizes, which means the hole with capacity 10 will come first, and then the hole with capacity 50 will come next, and then the hole with capacity 100 will come next. If I do this kind of sorting, right, and now if I search this list for the smallest fit possible, the best fit possible, here the first fit is going to act as the best fit. But then separating out the holes and then sorting them in the increasing order is going to have lot of impact when you are trying to free up the process. Now when we try to free up the process, they are no longer present in a way where this combining is possible. Earlier they are present in a way in which the combining, the merging of neighbors to form a bigger whole was possible, but now here the combining is not possible, isn't it? So anyway, it is going to be inefficient. And overall, the reason is why many of the algorithms are inefficient even if you try to change the data structures is allocation is going to happen, as well as deallocation is also going to happen frequently, as frequent as allocation is going to happen, isn't it? A process will arrive as well as a process will leave. So even though you try to optimize the allocation time, the deallocation time may be very high. So overall, the bottom line is first fit is the best one, and many of the existing systems, wherever this contiguous allocation with dynamic partitioning is used, first fit is used, and no other algorithm is actually beating this first fit. People have tried various variations, and they are trying to optimize one kind of either allocation or deallocation, but then not both of them. First fit is working fine, right? So in C, malloc, we shall again see it in the C programming language, but remember that in C, malloc function is going to use first fit algorithm, and it is faster compared to any other algorithms, right? Fine.